Welcome, Algebra 2 Common Core students, to the first of many Regents review videos for the Algebra 2 Common Core exam. This is going to be the Algebra 2 Regents exam for June 2016, the very first exam that was given for this subject. These are going to be the solutions to Part 1. Questions 1 through 12 of this exam. Now, before we begin, before I go on to my little spiel, if this is the first time you're reviewing for the Algebra 2 Regents and you're reviewing this particular exam, I'm only going to say this once. I'm not going to say it every video. The Algebra 2 Regents is a doable exam. It really is. But the problem is, it's difficult if you don't study. If you passed the geometry Regents last year, you understand that that was a pretty challenging Regents. Whatever year you took it, geometry's hard. In my opinion, the Algebra 2 Regents is more difficult than the geometry Regents, but it is more passable, if that's even English. It's easier to pass this exam as compared to geometry. So, just keep that in the back of your brain. Before we begin, do not, under any circumstances, take these answers and put them on a piece of paper and call them your own. It is a hard exam. So you need to do the problems by yourself, or else you're going to go to summer school and you're not going to be happy. Believe me, you don't want to do it. Make sure that you hit that subscribe button down below if you like the content that you're seeing. And consider becoming a patron on my Patreon page. I would greatly appreciate it. And visit my website at www.nysmathregentsprep.com for more math content in Algebra 2. And since this is the final Regents exam that you need to take in math in high school, you will be seeing some AP calculus stuff come out. If you are getting to that far level of mathematics, you will see that come in the near future. If you're watching this in 2018, it's probably going to come out in like 2 years. If you're watching it later, then it'll probably be out by then. And I use the Ti-Nspire CX calculator heavily for this course. Make sure that you get one. The link is on my website. Without further ado, let's begin the first June 2016 exam, Algebra 2 Common Core. Here we go. Number 1 says, when b is greater than 0 and d is a positive integer, the expression 3b raised to the 2 over d power is equivalent to what? Okay, so this is just a basic concept that you need to know about exponents, okay? So we have 3b raised to the 2 over d power. What your teacher should have taught you is something on the lines of this. This over here, that 2 represents your power, and that d on the bottom represents a root. How I teach my students is this, just a little trick, okay? The trick is you have a plant, okay, a flower, which is a plant, and you have the roots on the bottom. The plant, which is a P, the plant is on the top. The roots, which is an R, the roots are on the bottom. So it's power over root, plant over root. Make sure you know it. So what we're going to do is you could actually rewrite this power as a radical. That's basically what it's testing you here, folks. So what I'm going to do is this power is going to be squaring whatever you're doing. And this root goes in the index. So let's talk about radicals for a second. A radical looks like this, okay? With the radicand underneath the radical, there's an index over here, and it's raised to some power. That's usually how a radical looks. So again, this means index. This n here is your radicand. And that p is your power, okay? So we need to somehow write 3b raised to the 2d like this. That's our goal. So what I'm going to do is I'm going to take my power of 2 and I'm going to raise it to the 3b. So I'm going to write 3b, okay, raised to the second power, and it's the d root of this. So it's the d root, okay? What I tell my students as well, since this is a root, the root goes in the cup. It's a little cup over here. You could think of that as well. And your answer for this one is choice 4. Now, I want to just explain one more thing before I move on. They tell you that b is greater than 0 and d is a positive integer. They tell you that for a very specific reason. Because if d was a negative integer, you would actually move this whole radical down to the denominator because you cannot have negative exponents. It has to be positive. That's how it's normally written, okay? So D is positive. That's great. It's by itself. If it was negative, you would have to move it down to the denominator, which your answer would be choice 1 if D was negative. And B has to be greater than 0 because or else you have imaginary roots, so that can't work either. So that's why your answer is choice 4. Moving on to number 2. Julie averaged 85 on the first 3 tests of the semester in her mathematics class. If she scores 93 on each of the remaining tests, her average will be a 90. Which equation could be used to determine how many tests T are left in the semester? So let's talk about this real quick. Her average is going to be a 90. They tell you that right in the background information. Her average will be a 90. So therefore, these numbers on the end are your averages. Well, clearly, get rid of the 93. So her average is not going to be a 93. That makes no sense. So get rid of choices 2 and 4. Okay? Now we're left with choices 1 and 3. Let's talk about what each thing means. What does that 255 mean? Well, it says that Julie averaged an 85 on her first 3 exams. Well, 85 times 3 is equal to 255. So that's where they're getting that number from. Then it says if she scores a 93 on each of the remaining tests. So that means we got a 93 times T with the remaining exams. Okay? It all really comes down to the denominator. What in the world does the denominator mean in the context of these answers? Okay? What you should be thinking of right now is to calculate the average of something, you add up all the totals and divide by how many there were. So for example, let's just say I got 100 on 10 exams. Well, obviously I have 100 average, but that's easy. But let's just say you want to calculate it. I took 10 tests, got 100 on all of them. 10 tests times 100 gives you 1,000, and you divide that number 1,000 by the amount of exams that you took. In this case, it would be 10, which would give you 100 average. So you're looking here. Well, do I take the 3 exams that she already took and multiply it by the amount of tests, or do I take the 3 tests and add it to the amount of tests that she took after that? Your answer is choice 3, okay? It makes no sense to multiply. What if she took 4 tests, right? If she took 4 more tests and she already took 3, then she should be divided by the number 7, right? Well, the problem is if you have choice 1, that means that she took 12 tests. 3 times 4 is 12. She didn't take 12 tests. She only took 7. And that's just an example. She didn't have to take 7 tests. She could take 15. I don't care. But you have to add up those numbers, okay? You cannot multiply them. So that's why it's going to be choice 3. Number 3. Given I as the imaginary unit, 2 minus yi squared in simplest form is what? So this is just a basic foiling question. It's double distribution. So 2 minus yi, 2 minus yi, okay? I'm going to multiply everything throughout. Here we go. 2 times 2, 4. 2 times negative 2 times negative yi is negative 2yi. Negative yi times 2, negative 2yi. Now be careful here. This is where people get messed up. Negative yi times a negative yi is a positive y squared I squared. There's a 1 on the y's and there's a 1 on the i's. Okay, so remember when you're multiplying, you multiply the coefficients. In this case, we took a negative 1 times a negative 1, so it's a positive 1, and you add those exponents. Okay, now we're not quite there yet in simplest form. Okay, so what we need to do is we need to combine these negative 2yi and negative 2yi. So we get 4 minus 4yi plus y squared I squared. Now what you should know is you could rewrite the I squared as something else. I squared is the same thing as negative 1. So your answer is 4 minus 4yi, 4 minus 4yi minus y squared. And if you just rewrite that in descending power order, your answer is negative y squared minus 4yi plus 4. That, ladies and gentlemen, is your answer, which is going to be choice 2. Now, let's just say you did not know that I squared is negative 1. Let me show you how to get on your calculator. Pretty simple stuff. So go to your calculator down here. On the left-hand side of the Ti-Nspire, you're going to see down here it's a little pi button on the left. Click on the pi, and you see that little letter I? Take I, raise it to the second power, and it tells you the answer of -1. So you have that at your disposal. Pretty powerful calculator, right? So it tells you the powers of I. Oh yeah, we got it right. Choice 2 is your answer. Number 4. Which graph has the following characteristics? 3 real zeros. As x approaches -infinity, f of x approaches -infinity. And as x approaches infinity, f of x approaches infinity. So let's talk about what each thing means. First of all, you might not be familiar with this notation. So I'm going to put it to you in words. It's basically saying as x goes to the left, as the values of x goes to the left on the graph, the y values go down. All right, I'm using very simple terms here, not increasing or decreasing. I'm using simple terms. Now, for the next one, this is as x approaches infinity, f of x approaches infinity. This is saying as x goes to the right, the y values go up. Okay? So that's what those things are saying. Then the 3 real zeros means that the graph crosses 3 times. Okay? So, here we go. We have these 4 answers. I'm going to zoom it out a little bit here. So we have these 4 answers, right? First of all, 3 real zeros. Well, there's 1 0, 2 0, 3 0, 1 0, 2 0, 3 0. Okay. This is a problem here, folks. This right here is actually 2 zeros. This is 1 0. And this is 1 0. Probably thinking, whoa, slow it down there, Trevor. Where'd you get that 2 zeros from? I'll tell you why. There's this thing in mathematics called multiplicity. Okay? Multiplicity is defined as the repetition of roots. Okay? So there are some characteristics on a graph that tell you if the root repeats itself. Okay? Let me zoom in and really tell you what's going on here. Let me zoom in a little bit further here. Okay, so we have this graph. I'm going to erase some of this stuff just to show you what's really going on. These 2 things here, these roots, have multiplicity of 1, meaning that the root only repeats itself once. So I call these things, I call these a cut through. Okay? This root over here has a multiplicity of 2. Okay? I call this a bounce because obviously it's bouncing off of the x-axis. So this graph actually shows 4 roots, not 3. It's actually 4 roots. Okay? Same thing over here. We have a bounce, a cut through, and a cut through. This has 4 roots. So we know that choices 2 and 4 cannot be the answer. In addition, they don't have the right end behavior. They just don't. So now we're looking at these 2 answers up here. Now it all comes down to the end behavior. End behavior is just a fancy term for what's going on at those at the arrows of the graph, okay? So let's take a look. As x goes to the left, or x approaches -infinity, your y values, or f of x, approaches -infinity. So as x goes to the left, y should be going down. Okay. Let's take a look here. On this graph, it's showing that the y values are going up. On this graph, it's showing that the y values are going down as x approaches -infinity. Let's read the next one. As x approaches infinity, f of x approaches infinity. So as x goes to the right, the y values go up. Okay, as we go to the right, the y values should be going up. Right up. The only graph that shows the correct correlation is choice 3. Choice 3 is your answer. Choice 1 is showing the opposite, so that cannot be correct. All right. Not too bad of a question. Your answer is choice 3. Moving on to number 5. All right, so the solution set for the equation, the square root of 56 minus x equals x, is what? So, Should be second nature to solve for square root functions or square root equations. So in order to get rid of the square root, because you can't solve for an x underneath the square root, is you need to square both sides. Okay? Square both sides. So when you square a square root, you just take what's underneath the radical. So it's 56 minus x is equal to x squared. Okay. So now what we're going to do is we're going to move that 56 over, and we're going to move that x over. What we're going to do is we're going to factor this by the factoring methods of GCF dots trinomial, basic algebra 1 skills. So we get x squared plus x minus 56 equals 0. So now we got to think to ourselves, what adds to positive 1 and multiplies to give you negative 56? Well, those factors are x plus 8, x minus 7. Let's check. 8 times negative 7 is negative 56. 8 plus a negative 7 is a positive 1. Equals 0. Draw your t-bar. X plus 8 equals 0. Subtract that 8 on both sides. You get x equals negative 8. It's just as opposite of what's in the factor. We get x minus 7 equals 0. Add that 7 on both sides. We get x equals positive 7. Again, the opposite of what's in the factor. Now, my motto is check your answers. Check your answers. You have to check to see if negative 8 and positive 7 both work, because you're probably going to fall for choice 1. Choice 1 is not the answer, because one of these is extraneous. Extraneous means that the root does not work when you check it. So I'm going to check negative 8. So if I take negative 8 and I plug it back in, right? So we're going to check x equals negative 8. We get the square root of 56 minus a negative 8. Watch your signs. Is that equal to negative 8? Well, let's see. 56 minus negative 8. That's the square root of 64 equals negative 8. Does the square root of 64 is 8? Does 8 equal negative 8? It does not. So that's why that can't be the answer. Now, you might be thinking to yourself, and I totally understand if you are, you're like, wait a minute, Trevor. I thought that the square root of 64 is plus minus 8. You're absolutely correct. But it has to work for both. It doesn't work for positive 8. It could work for negative 8, but it doesn't work for positive 8. That means that it is extraneous. It craps out. Done. So that can't be it. Let's check x equals 7. Okay? X equals 7. It could be the null set. Who knows? We have the square root of 56 minus 7. Does that equal 7? 56 minus 7 is the square root of 49, which is equal to 7. Does 7 equal 7? Yes, it does. Now, you might be thinking to yourself, wait a minute, Trevor, I thought that 7 equals plus or minus 7. Why is that the answer? Because the answer is choice 3. Why is that the answer? Because we're talking about positive numbers. It can't be a negative underneath there, or else you get an imaginary root. So that's why it's going to be choice 3. Okay? It's because 7 does equal 7. And I understand that your frustration with negative 8, but those don't work. And it's not choice 4 either. Okay, moving on to number 6. The zeros for f of x equals x to the 4th minus 4x cubed minus 9x squared plus 36x are what? So, the zeros, meaning that you're taking this equation and you're setting it equal to 0. So, we get x to the 4th minus 4x cubed minus 9x squared plus 36 equals 0. So what I'm going to do, with an x at the end. What I'm going to do is I'm going to factor out an x, because that's your GCF. You got to take out a GCF first. Take it out. You're left with x to the 3rd minus 4x squared minus 9x plus 36. That equals 0. So now what's going to happen is this is actually a special type of factoring. This is called group factoring. Okay? Group factoring occurs when you have 4 terms and you could take out a GCF and you're left with the same binomial. Okay? Let me show you what it means. So, what we get, I want a different color. So what we get is x with, I'm going to draw a bracket here. Take out the GCF of this binomial. The GCF of this is x squared. You're left with x minus 4. Now, you have to be left with the same binomial of x minus 4 over here. So you have to be careful with what you take out. If you take out a 9, you should be left with x minus 4. But is that 9 positive or negative? Well, if you take the positive 9 and you distribute it back in, you should get negative 9x plus 36. But if you take positive 9 and put it in, you get positive 9x minus 36. That's not the same thing as this. So you automatically know that this has to be negative. Okay? This is all equal to 0. So now what you need to do is you need to combine the x squared and the negative 9 into one factor. So let's go ahead and do that now. We get x with a bracket, x squared minus 9, and we only write x minus 4 once, not twice. That equals 0. Okay, now we can factor this by the difference of two perfect squares, by dots. So we have x, parenthesis, x plus 3, x minus 3, that's where the dots came from. And we have x minus 4, set that equal to 0. Okay? Now, just draw a triple T chart and set everything equal to 0 and solve. It's just the opposite of what's given. Well, if x is by itself, x equals 0. This is x equals negative 3, this x equals positive 3, and this is x is equal to 4. So these are your answers. These are your zeros. 0, negative 3, positive 3, and 4. That is going to be choice, I believe it's choice 1. Choice 1. Now, let's just say you did not know how to do that one by hand. I'm going to show you a way on the Ti-Nspire. Okay? Go to your calculator page. Go to menu. Okay? Go to algebra. Click on polynomial tools. And click on find the real roots of a polynomial. Now, let me tell you why it's not complex. Because your answers, all of your answers that they gave you are actually real roots. So click on real roots. And you got this polyroot button. Code. So now what you're literally going to type in x to the fourth minus 4x to the third minus 9x squared plus 36x. Now, on the Ti-Nspire, you cannot just press enter or else you get this memo. You get an error message. What you need to do is you need to put a comma x after this whole thing's done, because then it tells the calculator, hey, my variable is x, I need to solve for x. Ta-da! Negative 3, 0, positive 3, and 4. Another reason to get this calculator. Yeah. Go Texas Instruments. Your answer is choice 1 for that question. All right, moving on to number 7. Number 7. All right, Anne has a coin. Okay, the Algebra 2 Regents is doing this a lot. They like to throw in an example, and then they like to throw in this garbage. They like to tell you a scenario, then they like to compare this computer-generated model. I don't know what they're doing, but, you know, let's deal with it. So Anne has a coin. She does not know if it's a fair coin. A fair coin just means that you should be getting 50-50 each time you flip the coin. She flipped the coin 100 times and obtained 73 heads and 27 tails. She then ran a computer simulation of 200 samples of 100 fair coin flips. The output of the proportion of heads is shown below. Okay. Given the results of her coin flips and her computer simulation, which statement is most accurate? So let's analyze this data here. The mean is 0.497. Ladies and gentlemen, that is really, really close to 50%. It's 50-50. So the computer simulation is showing a fair coin just because the mean or the average is almost 50%. And the standard deviation is not even that far either. So notice how the most concentration of coins is in here, okay? Then you got some miscellaneous stuff over here. You got the 35 and then you got 60%, okay? So let's talk about this. It says in the experiment that she obtained 73 heads, okay? Well, she flipped the coin 100 times. That means that 73% of the time she got heads, and 27% of the time she got tails, okay? Look at this graph here, folks. Where's 73%? It's not even on here, which tells you that this coin that she flipped is not fair. Her coin is not fair. And the reason why is 73% are resulting in heads. No, that is not fair. It should be around 50-50, maybe 60-40, but it should not be 73 to 27. That's almost a 75% chance that she's going to be getting heads. Not fair at all. Okay? Moving on to number 8. Oh, this one is a beauty. All right, number 8 says, if g of c is 1 minus c squared and m of c is c plus 1, which statement is not true? So basically what they're doing is they're taking these functions and they're doing some operations. They're doing multiplication, addition, subtraction, and then division, okay? So it's your job to calculate all of these. Calculate the multiplication, calculate the addition, subtraction, division. So here we go. Choice 1. Let's go ahead and multiply these. So what we're doing is we're verifying that they got the right answer, okay? So let's take 1 minus c squared and multiply it to c plus 1, okay? When we multiply these, this is just basic foiling right here. First, outer, inner, last. 1 times c is c. 1 times 1 is 1. Negative c squared times c is negative c to the third, and negative c squared times 1 is negative c squared. When you combine all these in descending power order, or ascending power order, either one is fine, you get 1 plus c minus c squared minus c to the third. Is that the same thing up here? Yes, it is. So we know choice 1 is incorrect because we're looking for the statement that's not true. Okay? So we know that works. Let's take a look at choice 2. Choice 2, we're going to add those. So I'm going to take 1 minus c squared, and we're adding c plus 1. Okay? So in this case, the 1 plus 1 is just 2, and the c squared and the c can't combine, so it's just 2 plus c minus c squared. Is that the same thing up here? Yes, it is. So we know that that is correct. So we know that that is not the answer. Just be careful that you're finding the one that's not true. Let's take a look at choice 3. We're subtracting these now. Okay, you got to be careful with your signs, peoples. We're subtracting. So we have m first, so we get c plus 1, minus, in parentheses, 1 minus c squared. Distribute. We get c plus 1, negative times a positive 1 is a negative 1, negative times a negative is a positive c squared. That positive 1 and the negative 1 cancel in the middle, and you're left with c plus c squared. Is that the same thing? C plus c squared. So we're good. That's not the answer. Let's take a look at choice 4, and let's see why that's the answer. Choice 4, we're dividing. M divided by g. So you have c plus 1 divided by 1 minus c squared. Okay. So the best thing to do is to actually just factor the bottom by the difference of two perfect squares. So we get c plus 1 divided by 1 plus c, 1 minus c. Okay? So we get this. Now, the thing here is that addition is commutative. So we could actually cancel c plus 1 with 1 plus c because they're actually the same thing because, again, addition is commutative. You could change the order without changing the answer. So your answer is 1 over 1 minus c. That is not the same thing as negative 1 over 1 minus c. Let me just tell you why they tried to make it negative on you. Because they wanted you to see here, hey, c plus 1 and 1 plus c are just switching, okay? And you would think to put a negative 1. If you pick choice, if you did not pick choice 4 and you're like, how did the negative, like I got a negative 1, you confused the addition with subtraction. I'm going to change this a little bit. The answer is choice 4. If you want to move on, that's fine. But I'm going to explain to you what would happen if that c plus 1 was a c minus 1. If this was c minus 1 and this was still 1 minus c squared, you would get 1 plus c, 1 minus c. Look at this. The c minus 1 and the 1 minus c cancel, but since subtraction is not commutative, you need to put a negative 1. So that's maybe what you confuse it with if you did get a negative 1 as an answer. But you don't. Your answer is choice 4. That is how you do that question. Not too bad of a question if I get the right format. All right, there we go. All right, moving on to number 9. The heights of women in the United States are normally distributed with a mean of 64 inches and a standard deviation of 2.75 inches. The percent of women whose heights are between 64 and 69.5 inches to the nearest whole percent is what? So you should be thinking to yourself, go to your calculator, and you're using normal CDF. Okay? So what we're doing is we are taking, let's see, we need the mean, the standard deviation, and the min and the maximum. So the minimum height that you have is 64 inches. the maximum height that you have is 69.5 inches. The mean, which is your x bar, is 64, and your standard deviation is 2.75. By the way, ladies and gentlemen, if I'm not mistaken, the mean could also be represented as the letter mu in Greek. It's like this U with a tail at the end. This could also represent the mean. So what I'm going to do is I'm going to go to my calculator, okay? And I'm going to get rid of that. So what you're going to do is you're going to go to your calculator page, okay? Go to menu, go down to statistics, go to distributions, then go to normal CDF in your calculator. The lower bound, which is your minimum, is 64. Your upper bound is 69.5. Your mu, which is your mean, is 64. And your standard deviation is 2.75. Click OK. And you get an answer of 0.477, which is approximately equal to 48%. When you convert it into a percentage, then you round it. So that's why your answer is going to be choice 2 for this question. It's 48%. Okay? Not too bad. Moving on to number 10. The formula below can be used to model which scenario? So let's talk about this before we look at the answer choices. And it's a good habit to get into that, like not looking at the answer choices and then interpreting it yourself. So this is your first term. There's 3,000 of something. So this is your first term. Okay? Then we got 0.8 times a n minus 1. So that means that the terms after are 20% less than whatever came before it. And why did I say 20%? Because this 0.8 represents 1 minus the rate. Well, that r, the rate, is a 20% decrease. It's 1 minus 0.2. That's how they're getting the 0.8. So let's go ahead and look at these answers, okay? Here they are. The first row of a stadium is 3,000 seats. All right, that's good. The first row, first term, 3,000. And each row thereafter has 80 more seats than the row before it. No, this has nothing to do with addition. This is all multiplication. So this is wrong because this is showing addition. The last row of a stadium is 3,000 seats. Last row of a stadium? Then each row before it? That doesn't make any sense. A bank account starts with a deposit, okay, of $3,000, and each year it grows by 80%. Is this showing growth? This number here, if it was growth, it had to be greater than the number 1 to show growth, but it's not. Your answer is choice 4. The initial value of a specialty toy is $3,000, and its value of the in the following years is 20% less. Absolutely, it's 20% less. Okay? Or it could be rephrased as 80% of the original price. That could also be phrased that way, but they decided to go with the 20%, and I just showed it to you how to do it up there. Number 11, probability question. Sean's team has a baseball game tomorrow. He pitches 50% of the games. There's a 40% chance of rain during the game tomorrow. If the probability that it rains, given that Steven pitches, is 40%, it can be concluded that these two events are what? So, here we go. I'm going to write a whole bunch of words because probability is a whole bunch of words. So, I'm going to write this down. Two events, A and B. Whatever A is and whatever B is. So, A could be me swimming, and then B could, I don't know, B could be me having a drink. I don't know, swimming and drink. Whatever it is. So, two events, A and B, whatever they are considered independent, okay? They're considered independent, which means they have nothing to do with each other. If the probability of A given, that vertical line means given, if the probability of A given B is equal to the probability of A, okay? So in this case, they tell you this. So the probability that it rains, given that Sean pitches, is 40%. Okay? So, In this case, the probability that it rains. So rain, in this case, rain is your event A. The pitching is your event B. So they tell you this. The probability of rain given pitching is 40%. Okay? So now, what is the probability of A? Well, the probability of A is 40%. There's a 40% chance of rain tomorrow. So the probability that it rains is 40%. Okay. Well, as you can see here, look at this. The probability of A given B is equal to the probability of A. If these things are equal, they're independent. 40%, they're equal. Therefore, your answer is independent. Your answer is choice 1. Pretty simple question. Not too bad. Probability could be a lot worse than that. And the last question of this, number 12. A solution to the equation 2x squared plus 3x plus 2 equals 0 is what? So I see a whole bunch of radicals. I see a whole bunch of i's. Your best thing to do is the quadratic formula, which, by the way, it is given on your reference sheet. So the quadratic formula is x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Okay? In this case, your a is 2, your b is 3, your c is 2. Go ahead and plug it in. So we get negative 3 plus minus the square root. b is 3, square it, minus 4 times 2 times 2, all over 2 times 2. So we get negative 3 plus minus the square root. 3 squared is 9 minus, let's see, this is 16, all over 4. Okay? Let's keep on going. So, 9 minus 16 is the square root of negative 7 all over 4. Okay? So we're almost done with this. But, you cannot leave it as this. The square root of negative 7 can be simplified like this. If you take the square root of negative 7, you got to take out a power of I. You cannot take a square root of a negative number. So you got to take out the square root of negative 1 and the square root of 7. Well, you know that the square root of negative 1 is your power of I. That's the definition of I. The square root of negative 1 is the power of I. So we have I radical 7. Okay, we're almost there. So we get negative 3 plus minus I radical 7 all over 4. Now, all the answer choices show it separated, so I heart division. You could draw a little heart, I heart division. So we just split it up into different pieces. So we get negative 3 over 4 plus minus 1/4 I radical 7. And that is your answer, which is going to be choice 1. Choice 1 is the answer to that question. All right, that's the conclusion of this video. Not too bad of a multiple choice section at the moment. I hope that you enjoyed or at least found it helpful. Make sure that you hit that subscribe button down below if you like the content that I produce. Consider becoming a patron on my Patreon page. I would greatly appreciate it if you could help me out a little bit financially. Just $1 can keep this channel going forever. And make sure that you visit my website at www.nysmathreadersprep.com. The Patreon page and my website links are in the description below. You'll find a lot of content on my website for Algebra 2 and future math subjects, and I hope to see you soon.